Well, this laboratory is just, we can break anything, right? So
this is where you come to break
This is
stuff.
where you come to break stuff.
This is Bob Duchesne's Wild Maine. Over the last few months, I've made 3 trips to the University of Maine. In the center of campus, there is a small cluster of buildings that are creating the jobs of the future. Maine jobs, using Maine wood and materials. Loyal listeners already know that there are big changes going on in Maine's forest products industry. Older paper mills have shut down, but newer mills have added capacity in the state. Yet these may require a different mix of forest feedstocks than what the older mills used. Plus, low prices for oil and gas have depressed electricity prices, meaning we can't even burn our wood to make electricity at a reasonable cost. So, lots of things are going bad for the forest products industry. And that's all on the front pages. What you may not know is what's going good. And we're about to pay that another visit. We're heading into the Advanced Structures Composites Center. The what? Well, hang on. Bob Duchesne's Wild Maine is brought to you by Hammond Lumber, Napa Auto Parts, Doors Equipment, and EBS. Let me refresh your memory. In January, I spent an hour with Mike Bilodeau at the Process Development Center on campus, and we learned that if you take wood and break it down into tiniest fibers, nanofibers, you can put it back together in mysterious ways to make stuff. The same fibers can be used to make something very light, like insulation, or very dense, like armor. It just depends on how much air and glue you put into it. Yeah, I'm way oversimplifying here, but the feedstock is pretty simple stuff. The kind of low-value forest products residue that we're having a hard time finding markets for right now. In other words, it's exactly what we need. Then, I returned to campus and spent an hour with Habib Dagher in the Advanced Structures Composites Center, and we learned about using Maine wood in inventive ways to make buildings that are bomb-proof and tents that are blast-proof. We learned about how to test huge wind turbine blades to see if we could break them. And we visited the wave tank, capable of simulating the kind of huge ocean storm you only get once in every 500 years. We even witnessed new composite technology that will help men land on Mars. Or back here on Earth, how to build a bridge out of tubes you can carry in a backpack. All that stuff is happening right in our own backyard at the University of Maine. Today, we'll see what else is being made out of Maine wood.
Well, Bob, my name is Steve Shaler. I'm director of the School of Forest Resources and associate director of the Composites Center at the University of Maine.
As today's show begins, Steve and I have entered the structural testing lab, where they try to make stuff so strong they can't break it. We've walked by their bridge in a backpack, and we've entered a side room. In earlier shows, we've been all over this building, but we haven't been in this room.
So what we're walking into here is the composites, Strand Composites Laboratory. This has been, we built this probably 10, 12 years ago now. What we have in here is equipment that represents wood composite manufacturers, specifically oriented strand board and laminated strand lumber. Here in Maine, Huber makes that product up at their mill in Easton, and LP Building Products has their LSL mill in Holton, in New Limerick, Maine.
That's right. It's one thing to create new products. It's another to create new jobs. All of this research has to eventually mean commercialization. Fortunately, we already have companies in Maine making strand board. With the help of the University of Maine, we can make better strand board and outcompete the world.
So we have the scale equipment here that replicates their manufacturing process. So what happens in here is we can start with logs that come in, and that's a great thing for students to do, is to debark logs. although
say, that sounds exciting. Where can I sign up for that?
Hopefully they come debarked. All right. We actually have a heated log tank. So, for example, in industry, in the winter, right, they have to heat up their logs before they process it. So we're able to simulate that if we come with frozen logs. Sometimes the logs come already. And then the next process is what's called stranding, where you make little pieces of wood from big pieces of wood. And so most of you have seen what's called the oriented strand board, or Advantech is one of the trade names. And you'll see those individual pieces of wood that are 4 inches long, something like that. And so those come from usually aspen here in Maine, in Canada, In southern parts of the U.S., they'll use southern yellow pine, but aspen's really the best stuff. So what we make here in Maine is top notch. So what's called a strander takes that log, turns it into little pieces. Then we have a screening system, a drying system. You got to get rid of the water. And then over here is what's called our blending equipment. And so you have these small pieces of wood, and you spray on adhesives, you spray on waxes, or other additives. There's a lot of research, and what we're doing here is a lot of industrial research for companies that I can't talk about, of course. But this is a really recognized laboratory that many companies come here, not only the ones in the state, but other companies, to look at new ways of doing things to improve their products. Okay. So there's a lot of work on using different kinds of adhesives that have that have value.
Let me back up. A few minutes ago, I mentioned a previous episode of Bob Duchesne's Wild Maine that looked at what Maine is doing with nanofibers. That's breaking down wood and other cellulosic feedstocks into the tiniest microscopic fibers and then recombining them into new inventions. What this lab is doing is just breaking wood down into flakes, chips, and smaller bits of wood and gluing them back together in the shape we want. The wood is still basically wood. It's the adhesives that we're trying to get reinvented and improved. And this lab can test to see how well they're working.
This is
What's the difference between particle board and strand board, Andy?
Well, particle board, there's two things.
Because I don't always get the terms right.
Yeah. Well, particle board is what you might see that under your floors, like underlayment, or you'll see it inside furniture. And that's particles that are like little, if you look under a microscope, they'd be little cubes or little, small chunks like that. And they're glued together typically with what's called a urea formaldehyde. Yeah. It's not real strong, but you can have a very smooth surface. So that's why it's good on furniture and under floors. So that's particle board. Oriented strand board, some people call it chipboard, is got those bigger pieces of wood that are maybe 3-4 inches long. So it's the same kind of thing. You got a piece of wood, you make a little piece of wood, you add glue to it, you heat it up, push it together, and you got a big piece of wood. Bigger piece than you started. And
is it stronger than, let's say, plywood or a big slab of normal hardwood, or what's the advantage of doing it that way?
Well, these composites, the particle board and the oriented strand board really competes with plywood. It has very similar properties. And particle board, the properties aren't as good, but it's cheaper.
Yeah.
Okay, so it's the right fit for the job.
So for an application that doesn't have to take a big load, particle board's fine.
That's right.
But you put stress on it, you're going to need something tougher. Well, let's relate this to Maine jobs.
Sure.
Sure. I mean, obviously, paper making is not what it once was. We're making a transition to newer industries.
Right.
Where does all this wood and this technology fit into that picture?
Well, the two mills that are in the state right now have both invested over $200 million in their facilities in the last 10 years. And, of course, that's a big to improve what they do.
Right.
All the way from robotic systems to press systems. I mean, major investments. And, of course, that's key to compete in the global marketplace. So they provide jobs for the folks in the woods because they start with the trees. Again, a lot of aspen. Here, our university forest, actually, we have a few thousand acres at the university that we manage. We were just harvesting some land, and there was a bunch of aspen on there. Some people call it popple. We sold it to one of the mills up there. They were so it comes for hundreds of miles away. And then they have their the people there that work at the facilities, all the way from mill managers to millwrights to front office staff. So just like any business. I'm not sure what the numbers of people that work there, but again, those are in the northern part, the rural part of the state. So they have an outsized, a large impact on, especially in Aroostook County. They're really key employers.
Essentially, it's new markets for wood. The old wood would have gone into pulp. New wood can go into this.
That's right. New markets, new applications, always evolving. You've got the engineering involved in how do you make things, combine things in different ways. A lot of innovation, and we're working with those mills, working with these companies. There's the zip system. that they're putting coverings on. Some of these companies are working on how do you make fire retardants, how do you give other properties so they can sell their product, improve it, but have it go into new applications. So there's more demand. So they put a second shift, they put a third shift on, which of course then it has more jobs.
Yep, very good. We're taking another tour of the Advanced Structures and Composites Center at the University of Maine. Dr. Steve Shaler is the Associate Director of that, and he's the Director of the School of Forest Resources. This is our third visit this year to this center on the Orono campus, and we're taking one last look at where Maine's new jobs are going to come from. Next question, how does this work? Does the university invent stuff and then shop it around, or do companies come to the university for their problems? Well, stand by. This is Bob Duchesne's Wild Maine on Sports Radio 92.9 The Ticket. It's Bob Duchesne's Wild Maine on Sports Radio 92.9 The Ticket. I'm at the Advanced Structures and Composites Center at the University of Maine. Dr. Steve Shaler is my host. He is Associate Director of the Center, and he's the Director of the School of Forest Resources. In this lab, they invent stuff made out of Maine wood. They also improve the way we make things out of wood. So my next question to you, Steve, is this. How does this all work? Does the university invent stuff and then shop it around? Or do companies come to you for their problems?
We have people do come here. Actually, over the last few months, we've had quite a few companies and people interested in whether we're working on certain technologies or what is coming up here. In some cases, we've been talking. In some cases, we don't. But there's innovation going on, and this facility here is one of the best in North America. This pilot line for strand composites, and so again, we've had people come internationally here to do work in projects. So it's an impact in Maine. And this line here, we employ 3 full-time people doing this. So it's had an economic impact right here at the university.
So we're walking over to Norway spruce. So tell me the backstory on Norway spruce. That's not a Maine native, but we started growing it here. How come?
Well, that was back in the 30s, the CCC days, where there was a lot of work actually on planting trees because we had a lot of agricultural land that was kind of laying fallow here on the east. And it's a commonly used, a very important commercial species in Europe. And they said, well, let's soil control, let's revitalize, give jobs to people planting trees, and that was selected as a good candidate.
And then 70 years later, 80 years later, we say, what are we going to do with it?
Well, the Norway spruce has been used for pulp and paper over the years, and because it grows fast and a lot of volume. But if you're going to use it, and it's a beautiful tree, and the wood looks fabulous, but the way the building codes work is in order to build something and what's called a grade stamp. And so the spruce mills here in the state, the softwood mills, and I'm not talking white pine mills, which use white pine, which is soft, but that's a different market.
It is.
But construction lumber.
Yeah.
Okay, because it's used in buildings, and because that can have an impact on life and safety, it has to be certified that it's okay.
Yeah.
All right. And that grade stamp, and so how that's done at most places here in the state is you have lumber graders, and they'll see how many knots is it, what size is it, how does it look, and they'll give it a grade. It's a number 2, it's a number 1, whatever that is. Well, this Norway spruce is, and we have black spruce, we have a lot of red spruce.
All those I'm familiar with.
Yeah, those are used for lumber right now.
Right.
But Norway spruce had never been tested in the U.S. to make sure that it would be safe if you built with it. And so you legally couldn't use it.
Even though it has probably the same properties as most of the other spruces.
That's right.
Okay.
And growing, and it's right there, and now 70, 80 years old, beautiful, beautiful trees, you couldn't use it. And so we worked with the Northeast Lumber Manufacturers Association, and they're an organization in Maine. Well, they represent the whole Northeast and Upper Midwest, but they're based in, I should remember the city, between Yarmouth and Portland.
Cumberland?
Maybe Cumberland.
Wouldn't surprise me.
It's a small little place.
Yeah.
Anyway,
it's based down there.
Yeah, but actually, that's their headquarters. Yeah. And so here's all this great tree that the sawmills would love to use, and the landowners would love. I mean, a saw log is worth more than a pulpwood.
Yeah.
So they'd love to sell it. So everybody wins, but they couldn't do it.
Yeah.
So I was talking with the Lumber Manufacturers Association, and I said, they identified this as an issue, but we got to test a lot of wood. Well, this laboratory is just, we can break anything, right? So
this is where you come to break stuff.
This is where you come to break stuff.
Yeah.
And a long history of working with wood products. And so we collaborated with them. They identified where the trees were throughout the Northeast and the upper Midwest. They worked with sawmills to cut it into the lumber, dry the lumber, and then they shipped it to us. So it was a collaborative partner with the Lumber Manufacturers Association. We took all that lumber, they graded it, we broke it, measured things, did all the statistics and the computer kind of stuff, and then worked with them to submit that data and that information to the National Lumber Association. That was done this last year. A guy by the name of Russell Edgar, who works here, really spearheaded all of that work, and went through a process back and forth, and then it was finally approved this past fall, and I think it was the end of October.
Who are the big growers of Norway spruce? Because I go all over the Maine woods and I see black spruce groves and even red pine out there being grown. That was originally planted almost in plantations, but I haven't seen a lot of Norway spruce, so where is it?
It's around in different places. Scott Paper had put in some plantations back. That
would have been a ways ago.
Back a ways. These days, J.D. Irving has some plantations, and they use a variety of species, but that is one of the species that they use. Here in our university forest, we actually had some growing. So it kind of got put a lot of places, but there's not a huge. There is some. But the forests in Maine are primarily natural regeneration, so not so much plantations, but there's a little bit of it.
Irving does a lot of plantations. The old Plum Creek land, which is now warehouse, or I guess there was a lot there, but most of I think we started to do that and realized we didn't have to.
Well, trees grow around
here. They do.
Now, to go back to the earlier talk about OSB and the use of aspen, what I've been told is there's a lot of effort 10, 20 years ago to get rid of all that aspen. And now that's worth pretty good money. And they're always fighting to get more, actually.
That's tragically funny.
You go figure.
Because off the top of my head, I couldn't figure out what you used aspen for.
It's really valuable and a good. It makes a great product because it's it's not real dense.
Right.
And when you make these composites, you need to press them together. So if you start with something that's real heavy, you end up something that's really heavy. So you want to start light, and then you get something that's right in the middle.
Do this with a rock maple, and you'll break things.
I
got you.
So then we'll talk a little bit about cross-laminated timber.
Okay, let's do it.
A little bit on that. And so cross-laminated timber is a building technology that started out in Switzerland over 20 years ago. The Austrians have really pushed this. They have multiple plants, and Europe in general builds a lot of high-rise buildings with this product.
I'm looking at it, but I can't explain it.
Well, it's called. Sometimes people call it plywood on steroids. But it's what you do is we got that. Let's say that piece of Norway spruce. And you take a whole bunch of planks, 2x6s, 2x8s, 2x4s. You lay them on the ground, and so you got them next to each other. Then you're looking at that, and then you take some more boards and you do it crossways. So they're working at the other direction, and then you get pieces working the same way. And then you either do 3 layers or 5 layers or 7 layers and make a thicker product. The plants that are in the western part of the U.S. will make a panel that's maybe up to 10 feet high, 40 feet long. So there's plans to even go up to 60 feet long, and then 3, 5, or 7 pieces thick.
Now, I was a government major in college, so I learned nothing useful. So I'm I'm just guessing at this. But the reason you lay them perpendicular to each other if you, they have their different strengths and weaknesses. They bend a certain way with a grain.
That's right.
If you cross the grains and glue them together, then you've got something that's very rigid.
Yes, and so you've got
How close did I get?
Pretty close. You got the story, the right story, but not the whole story.
Okay.
But yeah, it gives you some properties in both directions.
Yeah. Mm-hmm.
So if you think of something on the floor, it's going to bend both ways.
Yeah.
But another real reason for that is wood shrinks and swells. All right. And so if you had everything running in the one direction, that cross direction you're going to have problems with. So if you go and you look at the door in your house, how is that wood door constructed? And if you see around the perimeter, it's the long direction is horizontal on the top, vertical on the side. And so what that does is make sure it doesn't shrink and swell too much. If all the boards were running up and down in the summer, that's going to block up your door frame.
Yeah.
So it's the same thing using this product in the building. You can't have it shrink or swell too much in your building, or that's going to create some issues.
Yeah.
Yeah.
It'll crack your windows.
Well, yeah,
It
yeah.
will.
So that's a really big part of it, is that dimensional stability is what we call.
Okay. The voice you hear belongs to Dr. Steve Shaler. He's Associate Director of the Advanced Structures and Composites Center, which is where we are, and he's the Director of the School of Forest Resources. When we return, we'll go inspect a wind turbine blade. In fact, it's one we've seen before, but we're going to look at it in an entirely different way. This is Bob Duchesne's Wild Maine on Sports Radio 92.9, The Ticket. This is Bob Duchesne's Wild Maine, Saturday mornings at 9, Sunday mornings at 8 on Sports Radio 92.9, The Ticket. I'm at the Advanced Structures and Composites Center at the University of Maine. Dr. Steve Shaler is showing me around, and we're talking about the future of Maine wood and the future of Maine jobs. Dr. Shaler knows both worlds. He's Associate Director of this center, and he directs the School of Forest Resources up here at the Orono campus. We spent the first half of this show in the structural testing lab. We're now wandered over to the offshore wind lab. In front of me, a large wind turbine blade. This is the third time I've seen it this year. First time I was on a legislative tour taking a close look at the future of Maine's economy. They were actively stressing this blade at that time. It's not quite the length of a football field, but it looks like it. And they were waving it up and down with massive equipment as fast as they could, trying to see if they could break it. Now, that was impressive. And I remember thinking, I'm not going anywhere near that thing. The second time was with Habib Dagher. He's the director of the center, and he's a composites guy. So we talked about the high-tech materials in this blade. But Dr. Steve Shaler is a wood guy, and even though I'm looking at the exact same mammoth blade, the view he gives me is entirely different.
Now this is interesting.
Yeah.
Most people don't think about it. You see this big windmill blade up here.
I do.
And that's, what is that? 70 feet long?
I was thinking I was going to give it 70 to 80 feet.
Okay.
I picture a football field, and it's not quite that long, but close.
Yeah, it's pretty big, right?
That's just one windmill blade
one,
right there.
One blade. That's
Yeah.
a commercial-sized blade, but it's not a big blade, but it's pretty darn big.
Yeah.
So normally what you'll see when you see the wind blades out there, they're all white. They've been painted and coated. But here's the blade without that white coating. And as you look at it, maybe let's walk over here a little bit, Bob. See all these measurement wires and things.
Yep.
But on the bottom of it, what does that look like to you?
On the bottom of the
blade. I mean, everything's sort of a greenish. There's kind of some fiberglass around the outside, but you can kind of see through the fiberglass on the bottom.
Oh, you can, can't you?
Yeah. Let's walk over here a little closer.
I didn't. Yeah. Now that I look closer, you can. Huh. So how thick
What does that look like?
Well, the whole thing looks like an airplane wing, but
Yeah. But if you see through that, that's actually balsa wood.
This blade is balsa wood?
All of that bottom, that's balsa wood.
Uh-huh.
And so a lot of these wind blades started, it's the same kind of boat technology. So that's called end-grain balsa.
Okay.
So, I don't know, I'm going to guess by by volume, 70% of that blade is wood. Mm-hmm. So your windmill blades are wood composites.
No kidding. Is that coming technology, or they're already doing that?
They're already doing that.
Yeah, okay.
Already doing
way.
that. Yeah, you don't tend to think of windmill blades as a wood composite.
Nope. Well, we got to rethink everything these days. You just can't make it out of aluminum and plastic anymore.
That's right. Wood is good.
Yes.
I've got a license plate. It's WDISGD.
Oh, just tell me.
Wood is good.
No,
without the O. So.
We keep walking. Steve Shaler and I are working our way towards some of the smaller labs, and we're stepping into one called the Nano Processing and Analytical Lab. A couple of months ago, we aired a show with Mike Bilodeau, who's also here in this lab. He taught us how to break down wood to its smallest fibers until it looks like a paste. You can then take that paste of nano fibers and work them hundreds of different ways, mix them a bunch of ways to make new products. One you can make in pretty impressive abundance is a type of foam, and we know that because we have just arrived at that lab.
So what we're here in one of the nanotechnology labs here at the Composite Center, and this is you can see over here. Mm-hmm. Here's some of the work on foams for insulation. It's over here.
Yep.
So I don't know if Mike talked about that.
Yeah, we did. I saw samples at his desk in his office.
Yep. So this is a spin-off company that's based here in Orono, where they've taken the nanocellulose and other additives, natural additives, and are creating a whole host of foams, flexible foams, rigid foams, and he's been very successful and is working with industry to commercialize the technology.
This is so much better than the stuff we're using now and have been using for decades.
Oh, absolutely.
Why aren't we doing it even faster? Why aren't people just beating down a path through the door saying we need to get that as much as you can make now? What slows us down?
You know, the scaling up costs and being first.
Yeah.
I think are probably part of it. A lot of people like to be second.
Yeah.
But cost to scale up. The way this is made right now, and it's going to cost money to scale it up to make it at the size that you're going to put on in houses. And so there's a risk with that. Mm-hmm. And then that's getting into business decisions. I know nothing about business, and that's technology is part of it. Yeah. And businesses is a lot more than just technology.
Well, I've heard that called the valley of death. You can develop anything, and then there's this little valley between developing it and commercializing it, and you need a lot of money to bridge that gap. That's maybe the weak link in the chain.
That's a hard one to get through, and it's all I've learned this term called de-risking. Mm-hmm. So when you're putting out a lot of money, you don't want there to be a lot of risk.
Right.
And in the research lab, we don't care. So that valley is where you're trying to do things to remove risk, so that the people that got the money at the end they're comfortable enough to go ahead and do it. Mm-hmm. And that's where, if we kind of get back to that talk about cross-laminated timber, is building with those products. And there's an 18-story building in Canada. There's a 3-story building in Massachusetts. There's nothing yet in the state of Maine. But we were talking with a contractor here on the state that was looking and actually specified that out. And it ended up costing them more than some of the traditional ways. And part of that was because they hadn't done it before. Yeah. And when you're not sure, when there's a little risk there, you build in a little cushion, right? Mm-hmm. Yep. And so this idea of having demonstration projects to give people the experience of building with these things. So maybe it's the cost, if it's an extra $100,000 to build a $10 million building. I'm pulling these numbers out of the air because people haven't used it before, so it's a little risky. If we can support it and say, well, here's the $100,000 for the difference. They get that experience and goes great, and then the next time, okay, I like this, I've got experience with it, and that goes away, and you've now increased the market and the demand for wood for construction and new value-added products from the state.
And what I've covered in a previous radio show is this foam, this insulation is all made out of the low-value wood that's being harvested right now. It used to go to pulp and doesn't.
Absolutely, absolutely. You can, because you're making stuff really, really small, and so you can start with something that's small.
Yeah. My guest is Dr. Steve Shaler. He's Associate Director of the Advanced Structures and Composites Center at the University of Maine and Director of the School of Forest Resources. We're looking at the future. So far, we've taken good old-fashioned Maine wood and we've glued it, laminated it, coated it, and made products so strong that you can now make tall buildings out of wood where it used to be you only used steel and concrete. Well, up next, we'll go even further We'll take some of that nanofiber paste, make something that looks like spaghetti, and use a 3D printer to make stuff. Now, this may seem far-fetched, but in Texas, they used a 3D printer to make a gun that worked. The metal firing pin was the only non-plastic component, and it successfully fired a .38 caliber bullet. 3D printers have made human body parts. Put in the right feedstock, you can print food. We'll meet one of those contraptions in a moment. This is Bob Duchesne's Wild Maine on Sports Radio 92.9, The Ticket. This is Bob Duchesne's Wild Maine on Sports Radio 92.9, The Ticket. Dr. Steve Shaler is Associate Director of the Advanced Structures and Composites Center at the University of Maine, and he's Director of the School of Forest Resources. This is my third visit to the campus to take a close look at the future, because much of what happens here might be the future of Maine wood. When you're out in the wilds of Maine thinking about the future, it can be hard to see the forest for the trees, but all that wood is fiber, and we've got a lot of it. And if you break it down into its smallest fibers, you can form it back into paste and make something really cool out of it with a 3D printer. But I'm getting ahead of myself. Back to Steve Shaler.
And what's done over here, Professor Doug Gardner, his area where he combines wood and plastics, many people have seen the wood plastic lumber on your deck.
Yep.
But here is some of the equipment that he's taking the nanocellulose and mixing it with the plastics and making a little, think of it as a fishing line. And you can see this over here.
Okay,
right?
yeah.
More like a weed whacker line, really. That's
exactly what that is. Yeah.
That's weed whacker stuff right there.
I hope it's stronger than my weed whacker line, because that breaks in a dandelion.
That's a market we haven't looked at, you know.
I got to tell you.
That's an idea.
That stuff breaks too quickly.
Yeah. Well, not only for the user, not for the supplier.
Yeah, right.
So you can see this is a little darker color. This plastic here, this is clear. This is nanocellulose that Doug has put in there, and it darkens the color. It looks a little bit more like wood. So what they're doing now is they're making this filament, and one of the things they're doing is to say, can I 3D print something? So we can go over here. Over here to the left.
I want to see this.
Let's go over here. And 3D printers come in all sizes, but here's a nice little, it's called a MakerBot. Comes in small, this is maybe 2 feet wide and 1.5 feet deep and 2.5 feet tall. And it's called a 3D printer. And in the back of it, if you look back here, there's the fishing line.
Yep.
Right? So what he's doing is, let's not just, it's not really fishing line, but that's what it looks like.
That's what it looks like.
Looks like a
weed whacker line, yep.
Yeah. So put the nanocellulose in there, which changes it, gives it some different properties, and now you can 3D print using nanocellulose plastic weed whacker line.
Yep. 3D print. Not everybody understands the term, and I've only seen it in action once.
Okay. It's also called additive manufacturing, which is even more obtuse of a term.
I don't understand that either.
So, let's describe 3D printing. So what you've got, let me get closer over here so I can lean down and look at it. So what we've got is a printer head. Think you got your inkjet printer, and normally when you print a piece of paper, right, that head goes left and right, and the paper comes to you.
Yep.
And when you print, you're putting one layer of ink down. So the way this 3D printer works is you got the printer head that moves left and right, but it also moves forward and backward, and the piece of paper doesn't change. Okay?
So you can tell the computer what shape this is supposed to look like when it's done.
That's right.
And it'll lay down the layers, one on top of each other.
One on top of each other.
Until you get a 3D object that matches the computer description.
You said you didn't know how this worked. That's exactly how it works.
Jeez.
And so you can build any shape. You can have a hole in the middle of something. You can have curves. And it's a multi-billion-dollar industry at this point, and is seeing more and more applications. And of course, what you use it for, in part, depends on that fishing line.
Yeah.
Okay. And how does it work?
Yeah. It's still the strength of the material you put into it.
That's right. That's right.
And it's not just the strength either. It may be the flexibility, the characteristics.
Yeah, and again, because when that comes out, you heat. In this case, you're heating it up, and then it's cooling down, and so things can shrink when it cools down.
Yeah.
And so, how do you keep it flat and all of those things?
Yeah. A lot of these materials would be sandable. You can work with it after it's done. So you rough something out and then smooth it out.
That's right. That's right. And wood, there's been a lot of studies on this nanocellulose. Sometimes people ask, there's been a lot of studies on what we call the toxicology. It's safe.
Well, it's wood.
It's wood.
It's wood.
It's safe.
Yep.
It's safe.
Mm-hmm.
So here's
Modeling.
Here's a poster on some of the research that they've been doing that's got some pictures.
Now let's describe this for radio.
Oh, there we go.
The big trick.
The big trick. That's why you guys get the big bucks.
yeah, one of these days.
So again, here's a picture showing the weed whacker line coming up to the head, and when you put it together, so when it gets shot out of the printing head, instead of a drop of ink, you got you're squeezing out a continuous line of things.
It's like pasta.
Like pasta. Yeah.
Soft pasta.
Yeah.
And then it hardens.
Yeah.
Yep.
That's right. And so what we see here is if you pulled out a microscope and looked real close, is you'd have these pieces of pasta next to each other, touching each other on the sides, and maybe some of the pasta's going at a different angle and curved. So you're making pasta.
And just laying it down, row on row.
Right. And if you make your own pasta and you lay it down and you don't dry it right, it ends up sticking together. Well, in this case, we want it to stick together.
And this is one of those applications I think is fascinating because this is what dentists do now.
That's right. You're pointing at a picture of a tooth.
Yep.
And so this technology where you can scan something, put it into the computer, say here's its 3D shape, and then you print it, start from the... You
do it with something with hard ceramics instead of wood, you can make yourself a tooth. And and I'm told by my dentist, who has now put 2 of these in my mouth, that it's going to last a lot longer than I am.
There's some people have looked and they've used bamboo, and they're doing this 3D printing. Maybe we should call it 3D pasta making. With bamboo and plastic. So you can do ceramics, you can do metals, or you can do plastics. And what we do up here is mostly with the plastics because it's hard to put wood in metal. But that's another story.
You're going to save that for another day, or you're going to reveal that now? Okay. Dr. Steve Shaler is showing me around. He's Associate Director of the Advanced Structures and Composites Center at the University of Maine and Director of the School of Forest Resources. We're looking at the whiz-bang high-tech stuff you can make out of cheap Maine wood. Much of this is the future of Maine's forest products industry. We used to just make paper out of it. Nowadays, you can make just about anything out of it. We've got one last door to go in, and this door has a radiation warning sign on it. I'll meet you back here in about 3 minutes. If I'm not here, whatever you do, don't go in this room. This is Bob Duchesne's Wild Maine on Sports Radio 92.9, The Ticket. Welcome back to Bob Duchesne's Wild Maine on Sports Radio 92.9, The Ticket. We're in the last lap of a technology tour at the University of Maine. Dr. Steve Shaler is showing me what you can now make out of wood. If you're worried all our paper-making jobs went away, well, you should be. But the future is unfolding right here in the Advanced Structures and Composites Center. There. So we're walking into a room that says caution X-ray radiation, big warning signs. What have I got myself into?
The dentist.
Yes.
And so one of the things they do at the dentist is they use X-rays, right?
Yes.
They get your bite wings. So what we have over here is called a vertical density gradient X-ray machine.
That's all gibberish to me.
Well, we use a lot of gibberish.
Yeah.
Well, there's your radiation sign over there, the X-ray. So you put a piece of wood in it, you close the door so you're safe, and inside there's an X-ray, and just like, but instead of just taking one shot, it's moving back and forth, and it sees the inside the material to see how dense it is. And we talked earlier about oriented strand board. When you make that, one of the tricks is you want to have it dense on the top and the bottom and not so dense in the middle, because that gives it what you want. I'm not going to talk. That's a good thing sometimes. Sometimes you want the density to be pretty much the same. And so in order to figure out how to get how you want it, you need to measure it. So this is a specific piece of equipment, and in mills in the state, they'll use X-rays a lot to look at what we call a basis weight of paper, or they'll see online manufacturing monitoring how they're making it.
I'm just going to guess again, but you would need to know the properties of wood before you could computer model how to break it. So would X-raying show you what's inside the wood so you understand what kind of stresses you can put it under?
X-rays can be used to see inside the material to understand, once you kind of look small, it's not just a lump of stuff, right?
Right.
You got holes, you got things running in different angles. And to understand, we use the term microstructure. All right. Yeah, you need to understand that, and that would be one way to get that.
Mm-hmm.
Over here, one last thing.
Yep, go ahead.
Is one of our atomic force microscopes, which, we'll make this.
One of these could have put me through college. I mean, that can't be cheap.
It can't be cheap. And I think this could be more impressive on the radio if we do this right than it is in person.
Yeah.
Because it's a thing in a box. But
it looks like a big smoker grill. Yeah. That's what it is.
Yeah, and that's all anti-vibration is what that's all about. Because inside you have a little diamond that's on the end of a stick, what we call so it's cantilevered out. And then there's a laser that shines on that. And as you move a material underneath it up and down, that bends the diamond on the end of the stick, and the laser sees how far the tip of the stick is moving up and down. But all really, really, really small.
Yeah.
So we talked about nanocellulose. This is used to see something that small. Or it's used to see how things are put together that small. We talked about the pasta maker, the 3D printing. This nanocellulose, some of it looks like pasta or lots of pieces of pasta. How are they put together, which is going to impact how things behave.
Now, when you talk small, you're talking something the size of a molecule, or
above the size of a molecule. It's maybe 10 times the diameter of your hair, a piece of your hair.
Okay.
It's pretty small.
Yeah.
It's pretty small.
Yeah, but when I come into a lab like this, small can mean like really, really small. So I needed a relative scale here.
Yeah. So we showed you things that are really big and some stuff that's really small. And all of those are important in the new economy, and understanding and developing new technology is not only what happens at the big scale, but why does it happen?
Yeah.
And sometimes that requires that you get really small to see why the big stuff happens.
Well, let's put in a pitch for value of education because we are not going to be able to compete making shoes.
No.
All those jobs went to Indonesia. All the old jobs Maine used to have are gone, and they're not coming back. This is not going to be cheap labor in America. No. It's going to be smart labor and people who can operate stuff and invent stuff and just do quality control, all the things that to watch over the robots do the work for us.
That's right.
All the engineers.
Yeah, the technology folks that, maybe you don't have an engineering degree, but you're still smart and you know how things work and understand the principles. So you don't need to design it, but you know how it works and how to use it. And technology is the key to be an investment.
Yes.
We talked about that earlier because all of that technology requires money.
Yep. And with that, we'll wrap up this visit with Steve Shaler at the Advanced Structures and Composites Center. My third trip into the future in this program, getting a glimpse of what new technology can do with all that wood out there in the Maine forest. To recap all of these visits, you can take some wood and reduce it down to the tiniest of fibers, nanofibers, and mix it up into a paste that can be molded into just about anything. In fact, you can run it through a 3D printer and tell the computer exactly what you want it to look like. It's like something right out of Star Trek. You can also take bigger chunks of wood and wood particles and glue them together in new ways to make building materials as strong as steel and concrete. And if you mix some of this wood with new age composite materials, you can send Maine wood onto scientific missions to Mars. Show of hands, how many listeners knew this kind of research was going on right in our own backyard? One last piece of business. Next Saturday is the 51st annual Kenduskeag Extreme Canoe Race, organized by Bangor Department of Parks and Rec. The fee is $25 per person pre-registration and $50 per person if you wait till after 1 o'clock next Friday, which is why I'm reminding you now. If you do wait to the last moment, you can register the same day next Saturday, but only from 6:30 to 7:30 at Mystic Tie Grange Hall in Kenduskeag. That's where the race is going to start. You've got to be at least 12 years of age, and anybody under the age of 16 must have an adult with them in the boat. Race registration is available online and at the Parks and Recreation Office at 647 Main Street in Bangor. If you want information or to register online, please go to www.bangorparksandrec.com. That's bangorparksandrec.com. Or you can call 992-4490. Bob Duchesne's Wild Maine returns next Saturday morning at 9 and Sunday morning at 8. And if everything goes according to plan, it'll be all about who gets to hunt a moose and who doesn't. We'll get an inside earful about how this is decided by the legislature, and trust me, it ain't pretty. If you can't wait that long to hear another episode, you can always go on our website at 929theticket.com and re-listen to an old show. They're all archived right there. Bob Duchesne's Wild Maine is brought to you by Hammond Lumber, Napa Auto Parts, Doors Equipment, and EBS. This is Sports Radio 92.9 The Ticket.